examine the consistency of the system of linear equations, you have 3 variables and 3 equations. First of all, let us rewrite the system of linear equations in matrix form. That is, the coefficient matrix, if I take it column wise, the coefficient of x to be written in the first column, 3. Now remember, be very careful that here in the second equation, the x term is not there. So the coefficient of x will be 0. So it is 3, 0, 3 in the first column, and minus 1, 2, and minus 5 in the second column. And the third column, the coefficient of z will be minus 2, minus 1, and because there is no z term in the third equation, it will be 0. So the coefficient matrix is 3, minus 1, minus 2, 0, 2, minus 1, 3, minus 5, 0, multiplied by the column matrix XYZ, the variable matrix, equal to the constant matrix 2, minus 1, 3. Symbolically, let us write it as A to the coefficient matrix into X to the variable matrix equal to B. I am writing for the constant matrix. And now to check, the first thing is to find the value of determinant A. What is A? A we are denoting to the coefficient matrix, which happens to be 3, minus 1, minus 2, 0, 2, minus 1, and 3, minus 5, 0. Let us work out the value of determinant A. So to find the determinant A, we can expand it along any one row or column, but here it will be convenient to expand it with third column because you have a 0. So expand along column 3. You already know the sign convention, plus, minus, plus, minus, plus, minus, plus, minus, plus. So in column 3 it is plus, minus, plus. So it will be plus means negative 2 times. It will be negative 2 times, delete the row and column through negative 2 and you get 0 minus 6, 0 minus 6. And then minus 1 will make it plus 1 times, delete the row and column through minus 1. So you get, you get minus 15 minus plus 3. Minus 15 plus 3. And what about the third element? That happens to be 0 only. So the value of determinant A is minus 2 into minus 6, you have 12, and from the other bracket also you get minus 12. So cancels, you get 0. So the value of determinant A is 0. So at this stage, you should know there are 2 possibilities, and you have to work out adjoint A. First we find adjoint A multiplied by B. In case it is not equal to 0, then it will be inconsistent. And in case the product of adjoint A into B is 0, it will be consistent with many solutions. The first case is inconsistent, second case it will be consistent. So that we'll decide later. Let us first work out the value of adjoint A. You know what is adjoint A? It is the transpose of a matrix obtained by replacing each element by the cofactors. And that is also decided by, you delete the row and column through a particular element whose cofactor you want, find the value of the remaining determinant, and impose the proper sign plus minus plus minus plus minus. You have been doing it. So now for A11, the first element is 3 in the first row, first column. Delete the row and column through it. What do you get? 0, minus 5 and minus 1, 5. So 0 minus 5, you get minus 5 with the plus sign, so it will be minus 5. At the second case, minus 1, delete the row and column through minus 1, you get 0 minus plus 3, minus 3, and it is minus times. So you get, so the first element, A11 place, you have minus 5. And then minus time, delete the row and column through minus 1, you get 0 minus plus 3, but to be taken with minus sign, so it will be minus 3. Similarly, you can work out rest of the elements with proper signs. of adjoint A yourself, and you will have minus 5, minus 3, minus 6, 10, 6, 12, and the elements of the third row will be 5, 3, 6. Take transpose of it, take the transpose, you get adjoint A equal to the elements of the first row, that is minus 5, minus 3, and minus 6, minus 5, minus 3, and minus 6. So take the transpose of it and you get adjoint A as the elements of the first row minus 5, minus 3, minus 6 come to the first column, and the elements of the second row 10, 6, 12, 10, 6, 12 we'll write in the second column, and 5, 6, 5, 3, 6 the elements of the third row in the third column. So now we have got adjoint A. Let us find out the product adjoint A into B. That is minus 5, 10, 5, minus 3, 6, 3, minus 6, 12, 6 multiplied by the B is the constant matrix, that is 2, minus 1, 3 multiplying with 2, minus 1, 3. What do you get? Taking the product, you get minus 10 plus 15, and you get, see here, multiplying with the second row, you get minus 6 plus 9, and in the third row you get minus 12 plus 18. So if you work it out, you get minus 20 and plus 15, minus 5 and minus 3 and minus 6. Obviously this is not equal to 0. So what do you conclude? That as determinant A is 0, but adjoint A into B is not equal to 0, the system of linear equations is inconsistent and has no solution. So that is about this particular fifth part. Examine the consistency of the system linear equations. Question 6. This is again, three variable, three equations. Put it in the matrix form first of all. You get the coefficient matrix as 5, minus 1, 4, 2, 3, 5. And the third row will be 5, negative 2, 6. The coefficient matrix, column matrix, XYZ equal to the column matrix, the constant matrix 5, 2, minus 1. We write it as AX equal to B. Now let us find out the value of determinant A. That is determinant of the coefficient matrix. The coefficient matrix happens to be 5, minus 1, 4, 2, 3, 5, and 5, negative 2, 5, negative 2, 6. Let us find out the value of determinant A. Let me expand along R1. So expanding along R1, you get 5 times, delete the row and column through 5, you get 18 and minus plus 10. Minus 1, so it will make it minus and minus plus, delete the row and column through minus 1, you get 12 minus 25, and plus 4 times, delete the row and column through 4, you get minus 4 minus 15. So work it out, you get 140 minus 13 minus 76, that is 140 minus 89, that is 51, not equal to 0. So here we find that determinant A is not equal to 0, so the system of linear equations is consistent with unique solution. It has got a unique solution.